In this video, I'm going to show you how to find coterminal angles in radians. Radians are tricky because they're frequently given in fraction form and they're counterintuitive, whereas degrees are pretty intuitive and we really kind of rely on 360 degrees as our frame of reference for anything circular. All right, so the key to this is remembering our goal, that we want an angle that's between 0 and 2 pi, which is within one full rotation. We don't want something that's negative. We don't want something that's multiple rotations. We want the smallest, most simple version of everything. Coterminal, meaning the terminal side is in the same position. In order to keep the terminal side in the same position, we're going to keep adding and subtracting full rotations so that the terminal side doesn't move. Our first example is negative. We know that we're going to have to add some form of 2 pi in order to get it there, between 0 and 2 pi radians. Well, 2 pi is an integer and 3 pi over 4 is a fraction. So in order to combine fractions, or in order to do anything with fractions, we need fractions. So we'll make a fraction. We want like denominators in order to be able to combine them. We like them to have the same denominator, so we can do that. We make it a 4. Now we need a numerator, so it's 8. So it's going to be double 4, which is 8. And now we get 8 pi over 4. All right, so now we're going to add that together. Now that we have like denominators, we can just add the numerator. So we get negative 3 plus 8, which is 5. And that's 5 pi over 4. All right, that is definitely between 0 and 2 pi because 5/4 is between 0 and 2. All right, let's keep going. The next one we have is a little bit different because it's more than 2 pi. So this has gone around the circle at least once, almost 3 times it looks like. So we're going to have to subtract away 2 pi now. Hopefully you're getting the hang of this. Yup, we're going to need to make fractions again. We want the denominator to match again. So we're going to make it a 6. We want a double 6 so that we don't change what's going on. We get 12 pi over 6. Now we're ready to subtract those away. 17 minus 12 is, again, 5. I didn't do that on purpose. And we'll keep the denominator the same at 6, and we're done because now we're between 0 and 2 pi because we're at 5 pi over 6. We're almost at 1 full pi, but that's definitely between 0 and 2 pi's. All right, last example we have here is, I guess, a larger negative value, and the same could be said if this was a larger positive value. Again, all we have to do is make sure that we're doing things in 2 pi increments. So with this one, because it's negative, we still need to add. So we're going to add 2 pi. Again, we need it to have a denominator that matches. So we're going to pick 3. Our numerator will be 6. Again, we're using pi's because that's typical for radians. All right, so now we're ready to see what happens here. We do negative 10 plus 6, and we get negative 4. That didn't really solve our problem, did it? See, if we look at our goal again, between 0 and 2 pi, that's still negative. So we're just going to have to do it again. Some textbooks or teachers will tell you to multiply 2 pi by things. You could do that. I choose to just do this over and over again because it really only takes a second. And how many times could the teacher really make you do this? I guess they could make you do it over and over and over again, but like, why would they do that? If they do it that way, yeah, they're forcing you to use their very specific formula where you multiply 2 pi with power. So you don't have to keep repetitiously doing this. And we get 2 pi over 3. So that right there is how you change angles that are given to you in radians that are not between 0 and 2 pi into angles in radians between 0 and 2 pi that are coterminal with the original.